Welcome back. So this video is going to be a little bit longer just because this is kind of a lengthy section with transformations. So the title is called Transformations of Sin x, but I'm actually going to be talking about both sine and cosine. So I already graphed the parent functions for sine and cosine, and I'm just going to kind of do a quick refresher on how I got this. So what I'm doing is I'm looking at the main points. So how I got my x values is I'm looking at the main points on the unit circle. So I'm just going to be looking at 0, 90, 180, 270, and 360, or 0 pi, pi over 2 pi, 3 pi over 2, and 2 pi. And remember, sine is the height of the triangle. So we're looking at the y value. So it would be, we would have 0, and then 1, and then 0, and then -1, and then back to 0. So that's how I got that graph. And remember, we talked about this before we left for this break, but the domain is all real numbers, and the range would be between -1 and 1. Now going to cosine. So cosine is that horizontal distance. So in other words, we're going to be talking about x. So I use the same x values, but to get my outputs, we look at those x values on the unit circle. So that would be 1, 0, -1, 0, 1. And the reason I have these parent functions here is because we're going to be doing transformations, so I want us to be able to kind of refer back to what the originals looked like. Okay, so we're going to do a few examples here. And just as a refresher as well, because we did this before we left, the general equation is going to look something like this, and it's going to be the same for sine and cosine. So y equals a cosine x minus h plus k, and a is going to represent your amplitude or the vertical stretch, which is going to be the height above the midline, okay? And we'll talk about that as we go through. H is going to be your horizontal translation, so moving it right or left. And K is going to be the vertical translation, or the height above the, or sorry, not the height above the midline, it is the midline. All right, so we're going to go ahead and do a couple examples practicing this. And obviously, I didn't go through the transformations on cosine because they're the same. So we are going to be doing quite a few just because this can get confusing. So we're going to start off with y equals 2 sine x plus 1. Okay, so what I like to do is actually use the original table. So in other words, I'm going to use the original points as my reference points, and I'm going to transform them. So think about, I know on the past couple tests you've had piecewise graphs, and when you transform them, you use the original points and transform those points. Okay, so what we need to do, I'm looking at the different transformations that are occurring. So we have this 2, which is going to be a vertical stretch of 2, or an amplitude of 2. And then we have this positive 1, which means it's going to go up 1, and that's actually going to be the midline. So we can see that in this case, nothing is affecting our x values. Okay, so what I'm going to do is create a new table, and I'm using those reference points. So I know nothing's going to affect the x, so I'm going to keep 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then I'm going to use the original parent function y values and transform them. So when we look at 0, the y value is 0. So I take 0, I multiply by 2, which is 0, and I add 1. Well, the nice thing is I know that pi and 2 pi will be exactly the same, because if we look back at the original, we have this one's the same, this one, and this one. So those y values will all stay the same. Okay, going back is we have the pi over 2 and 2 pi. I'm going to make that smaller. Okay, so pi over 2 and 3 pi over 2. Well, we know at pi over 2 it was 1, so we multiply by 2 and we get 2, plus 1 we get 3. At 3 pi over 2 it's negative 1, multiply by 2 we get negative 2, plus 1 we get negative 1. Okay, so we're going to go ahead and set up our graph. Okay. All right. So I'm going to say that this is pi over 2, pi, 3 pi over 2, and 2 pi, 1, 2, 3, negative 1. Okay, so what I like to do with these graphs first is to put in your midline. So the midline for this graph is 1. So I'm going to go ahead and just do a dashed line. And the amplitude is 2. So the amplitude is the height above the midline. So that means I know the graph will go 2 above the midline, and it'll actually also go 2 below. So why I like to do this is that way I know that the graph has to be in between those two outside barriers. So then we go ahead and graph it. So we have pi 1, 3 pi over 2, negative 1, 2 pi 1. So it's going to look something like that, okay? And then we'll just answer a few questions. So the midline of this graph is going to be y equals 1, because the midline is y equals k. The amplitude is going to be 2. And then the period, so period is the length of the cycle, or how long it takes to complete one rotation, and that's going to be 2 pi. Now, the only thing that's going to change it is if we actually change the horizontal stretch or compression, which we're going to talk about in the next section. All right, so let's go ahead and try another one. And if this is too easy, you can fast forward, but we will get to more difficult ones. But okay, so we have y equals negative 3 cosine x minus 2. And by the way, we know that these are all vertical translations because we don't have a parentheses with the x. So if it was like in parentheses x minus something, then that would be different. Okay, so again, I'm going to use my reference points, so from the original cosine parent function. So once again, nothing is affecting the x, so we use our same x values. And then for the y values, we have to multiply them by negative 3 and then subtract 2. So this one, it has an amplitude of 3. That's from here. We're moving it down 2, but we also have this negative sign which reflects it, okay? And because we're reflecting across the x-axis, that would affect all the y values. All right, so cosine also obviously has a pattern. So 0 and 2 pi have the same y values, which are 1. So you multiply by negative 3 and you get negative 3, and you subtract 2 and you get negative 5. So that's going to be the same for both of these. For pi over 2 and 3 pi over 2, both of their y values are 0. So you multiply by negative 3 and you get 0. You subtract 2, you get negative 2. And lastly, pi has a y value of negative 1. So you multiply by negative 3 and you get 3. Minus 2, you get 1. Set up the graph. All right. So again, I'm going to go by pi over 2, pi, 3 pi over 2, and 2 pi. And then these are just going by ones. So just like I did before, the first thing I am going to do is actually set up my midline. So my midline is at negative 2. So I'm going to go ahead and do a horizontal line at negative 2. And then my amplitude, even though it says negative 3, it's just 3. So when we're asking for the amplitude, it's just 3. So it goes 3 above the midline and 3 below the midline. All right, then I start graphing. So I know my graph has to be in between all of these lines. All right, so it's going to look something like this, and then I know that it'll have to go up that way and up that way. So going back to those questions, the midline is going to be y equals -2. The amplitude is going to be, oops, I don't know why I spelled that wrong. Okay, so the amplitude is going to be 3, and once again, the period is still 2 pi. All right, a couple more examples. So now we're going to add a horizontal translation. So we'll start off pretty easy. So we're just going to do y equals sine, and then x plus pi over 2. So we only have one transformation, and that's a horizontal translation, and we're moving it left pi over 2. So I know on the classwork they did moving it over in radians, which gets a little confusing. So we'll typically only see it, and when I say radians, I mean like 2 radians. So we're going to see it in terms of like pi over 2, pi, 3 pi over 2. All right, so we're going to, again, use our parent function. This time, the only thing that's changing is the x value. So I'm going to go ahead and put in our y values of our parent function because nothing is changing. And for the x values, we have to move everything over to the left pi over 2. So 0, if we move it over left pi over 2, becomes negative pi over 2. Pi over 2 becomes 0. Pi becomes pi over 2. 3 pi over 2 becomes pi. And 2 pi becomes 3 pi over 2. Okay, so from there, we're going to go ahead and graph this. All right, and I'm going to leave a little bit more room on the x-axis on the left side. Okay, and I guess I should probably label these. So this would be negative pi over 2, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so we will again start. We don't actually need to do the midline and amplitude. You could. And again, when I'm doing this, this is all just recommendations. You don't have to put these in every time, but it just kind of gives you a guideline of where your graph is going to be. Okay, then we start graphing. So we have 0, 1, 0, -1, 1. So it's going to look something like that. So the midline this time is y equals 0. The amplitude is 1. And the period. So even though we technically shifted it over, the graph finishes a cycle between negative pi over 2 and 3 pi over 2, which is still technically 2 pi. All right, so last example. If I could get my black pen. Okay, so this time we're going to do cosine. So y equals cosine x minus pi over 4, and then we're also going to do -1. All right, so both the x and y values are changing, so we're going to move all of the x values to the right pi over 4 and all of the y values down 1. So I'll do the y values first because that's easy. So 1 becomes 0, 0 becomes -1, -1 becomes -2, 0 becomes -1, and 1 becomes 0. Okay, so for the x values, it's a little bit trickier. So what we're going to do is we have the original starting value is 0. So we subtract pi over 4, so we get negative pi over 4. And then we had pi over 2. So if you do pi over 2, you can make that 2 pi over 4 minus pi over 4 would give us 3 pi over 4. The next original x value is pi. We can make that 4 pi over 4 minus pi over 4, which is plus, which is 5 pi over 4. And then we have 3 pi over 2, which you can make 6 pi over 4 plus pi over 4, which is 7 pi over 4. And then you can do 8 pi over 4 plus pi over 4, which is 9 pi over 4. And I realized I made a mistake back here because that should be adding because we're going to the right. So that should be pi over 4. My apologies. Okay, so we are going to go ahead and sketch this. So we've just been labeling pi over 2, pi, 3 pi over 2, and 2 pi, but we know in between would actually be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right, and then we're just going to go by ones as usual on the y, and we will pick a new color. So the midline is going to be -1, and then the amplitude is just 1 because there is no a value. All right, so we have pi over 4, 0, 3 pi over 4, -1, 5 pi over 4, messed that up, 5 pi over 4, -2, 7 pi over 4 here, and then, and I should add a 9 pi over 4, which would be 0. All right, so it's going to look something like that. And so we have the midline is y equals -1. The amplitude is 1, and the period still has not changed. It is still 2 pi. And I wanted to go back up. I know we graphed this one, but we didn't really talk about it. So obviously, since it's reflected, it's going to be facing downwards. So hopefully that helps you on transformations of trig functions. I know that was quite a lot.